Welcome to the Decarb Connect podcast. And this week, I'm really pleased to be joined by Sean Monkman, who is the Senior Vice President of Technology Development for CarbonCure. For those of you listening who aren't familiar with CarbonCure, they work within the concrete sector specifically. And what they do is help reduce carbon footprints by recycling CO2 so that it's actually part of the concrete mix. And we'll be hearing more about that. I've been excited to have Sean join us because of all of the kind of disruptor companies that I've got to know or hear about over the years. CarbonCure is one that just feels like every month, every quarter, there's more news coming out about the work that they're doing. So Sean, really pleased to have you come and join us for this episode. Thank you.
Thanks, Alex. So great opportunity to have this chat with you.
Great. Well, let's do this. Why don't we start with my standard guest question, which is, how have you arrived at this point in time? So, tell us a bit about how did you come to work with CarbonCure and how did you come to have this kind of experience and this role within the decarbonisation environment?
I've been with CarbonCure since the start, which the company itself is 10 years old. The idea or the genesis of the company extends back to an earlier firm called Carbon Sense Solutions, and my involvement there goes back 14 years. And how I got into this was I met the founder and CEO, Robert Niven, while I was at grad school at McGill University. We were both studying graduate work in civil engineering. We were both looking at two different aspects of a project, looking at recycling CO2 into concrete. He took that idea, developed a consortium of relevant industrial partners, got some government support, and then he started building a team so that I was, representing some of the technical knowledge needed to take this ideas from the lab and start industrializing them.
So had you always had this driver to be part of the kind of disruptor scene, or was that somewhat unexpected? How did this fit in with whatever the plan was that you had at that point in time?
It's probably an evolution. I think I've been in the concrete materials space for around 25 years, and my alignment with the more sustainable side of concrete goes back to the start of my PhD in 2004. And at that time, I wasn't looking for anything that necessarily was novel. This is just the opportunity I found. It was exciting. It was new. It felt like there was a moment to be had there with the conversation changing about concrete sustainability. So to have entered into this niche of CO2 utilization for concrete, weren't the first people to kind of look at this. You can go back to patents that came out in the late 1800s about using CO2 in concrete curing, but the moment had changed in the sense that this conversation about concrete sustainability was really starting to take off, and we needed to have a whole bunch of ideas at the table. So this was being in the right place at the right time, I think, in terms of capturing a little bit of the zeitgeist to say that CO2 is a challenge, but is it also an opportunity?
Yeah, so it's interesting thinking about the company that's been going for a decade, you said, and then obviously your work on that before then. So you've been in and around these decarbonisation conversations longer than me, longer than probably most people that are investing or working in this space now. And I'm interested in your perspective on how has the conversation changed over the years, do you think? I mean, I often say to people that even in the 2 and a bit years I've been going in this space, that it seems to have changed 2 or 3 times in tone during that time. How does it feel for you, and what's your sense of how the conversation has developed?
In my time in the field, I think the start of the conversation, at least in the wider context, would have been the work from the International Energy Agency and the World Business Council for Sustainable Development. They combined on producing a report for decarbonizing the cement industry, and they were kind of the first high-profile consensus-based reporting or goal setting, recognizing the challenge facing the industry, saying that, concrete is an important material. It will be needed for future infrastructure, but we do have to be conscious of the CO2 emissions. And if we are going to meet the demands of industry going forward, what are the things we need to do to lower the carbon footprints? With that first roadmap in 2009, it was entirely directed to the cement industry, so the producers of Portland cement. But what has evolved in the last 13 years or so has been a change in the thinking, where it's not just a cement industry problem, or at least the solutions are not just coming from the cement producers, but it's a whole value chain issue. There are roles to play from the concrete producers, the architects who are designing the buildings, the engineers who are approving the materials that would get used. And now, most of all, that you see this groundswell, governments. They buy half the concrete that's produced. Their infrastructure needs are enormous. So if they decide that sustainability is an important part of the concrete they buy, then the concrete will become more sustainable. And so we're starting to see this with actions in a number of different jurisdictions, where they're starting to put, maybe it's not just the lowest price or the longest durability that they're concerned with, but they're also concerned with the environmental impacts. And so that really wasn't something that was, part of the conversation back in 2009, but it's something that's kind of snowballing right now. There's been some recent announcements in Langley, BC, British Columbia, Vancouver Island, where their concrete procurement policy is sustainability driven. So this is something you're just going to see more and more of, and it's that piece that motivates all of these stakeholders to start taking action and moving forward in with this common goals of carbon reductions.
I think that's a really, really interesting thing, because I think, again, even sort of 2 or 3 years ago, probably you could point to 1 or 2 cities or regions that had some sort of legislation like that in place, but it does feel like bit by bit more and more of them are signing up to some sort of a quota or some sort of a an element of their procurement that relates to this.
Yeah, it's not concrete, just concrete. It's about the whole built environment. So concrete, of course, gets a lot of attention. The amount of concrete that's produced every year is estimated to be around 25 gigatons of concrete, which is on the order of 2 to 3 tons per citizen on Earth every year. And that's around 10 times the amount of all the other building materials put together, wood, glass, steel, and the like. So when you have this idea with driving the sustainability conversation for concrete, even if you can make modest and incremental improvements right away, that's meaningful, just due to the size of the opportunity or the size of the challenge.
One of the things when you and I were having our prep call that I thought was interesting because it coincided with another conversation I've been having, was that you mentioned that one of the things that you've observed kind of change a little over the last few years is this shift from talking about one route to decarbonisation, one way that it's going to happen, to, I think the phrase you used was stackable solutions. I wonder if you could speak to that a little bit.
If you go back to the genesis of these road mapping exercises, the IEA WBCSD one, they were clear about, the term in carbon reductions often is the wedge idea. So you talk about a carbon reduction goal sometime in the future, and if you start today, the impacts are small, but as they grow and scale up with time, the impacts start to grow, accumulate. And for them, there were 4 levers, and it was kind of like 3 of them were just doing better what we're already doing. So have lower carbon fuels, use more lower carbon materials as a substitute for clinkers, have more efficient kilns. And then the last one, which was actually about half of the carbon reductions, was carbon capture, utilization, and storage. So at the time, it's kind of like, well, we have to reduce it somehow, and our traditional levers won't get get us there alone. So we recognize the need to do something that is not quite ready. You're starting to see that readiness develop. There's announcements, it seems like once a month or so, maybe there's new projects related to carbon capture at cement plants. The capture is only part of it, though. The storage options, need to come on board. And ultimately, when you talk about this as a decarbonization pathway, it's going to be really challenging. So with the other roadmaps that have come in, where they get into other parts of the supply chain, they come up with other options that they'll certainly factor in. A lot of them would be related to efficiency, for example. If you're producing more efficient designs, maybe you'll use less concrete. If you use the right concrete for the job and you don't over-design your concrete, you probably can end up with a lower carbon impact of your structure. And then we get into the drivers from the architecture side. They have industry goals, and that's helping them make their decisions related to materials. And so concrete is always going to be a part of that conversation. We just need to be aware of all the options ahead of us that we can deploy to help drive down the carbon impacts.
Concrete and cement, this was something I was incredibly ignorant about when I first came into this space, but obviously concrete is one step further down the value chain from cement. So what additional environmental or climate challenges does it have on top of the way that cement itself is produced?
Cement is the main binder ingredient of concrete. It only typically makes up around 10% of the mass of the concrete, but 90 to 95% of the CO2 emissions for concrete are related to the cement. So the conversation about concrete sustainability as a unit of concrete is most of the attention, justifiably so, is going to go towards the binder. So if you can reduce the cement clinker that's in your binder, your blend of binder in your concrete, you can start making meaningful reductions. Within the value chain, the concrete producer can take a number of actions that are not specifically related to the binder, but do drive the sustainability conversation. And that, as a company, we're developing a suite of solutions that both help improve the sustainability of the concrete producer's offerings, but also recycle CO2. And so for the concrete producer, as said, the binder is a small portion of the concrete, but it's a far exceedingly large majority of the CO2 emissions. But you can get into the things, your options with aggregates. You can use recycled materials as aggregates, including recycled concrete. You can do things with the type of water that you use. If you recycle water from other parts of your process, perhaps you're reducing the freshwater consumption of your concrete. And then you get into some of the concepts we've been working on. We were a winner of the Energy COSIA Carbon XPrize last year for an idea to help concrete producers recycle their process water, which happens to have a lot of cement suspended in it like a dirty slurry that just gets produced. And so by treating this with CO2, you're not only mineralizing the CO2 and permanently removing it, you're allowing the producer an easier pathway to recycle this material back into their concrete mix as a partial replacement for mixed water and a partial replacement for virgin cement. So you have this kind of three-pronged offering for a concrete producer. It's not just sustainability. It's about efficiency of their materials. It's about even reducing their costs.
You've gone in there to this newer product within your kind of portfolio of products. Just if we step back a moment, like the core product, which is where you're recycling CO2 and this is then put back into the concrete mix. Tell us more about that and how that works. So how does that work to effectively sequester CO2? Why does it work to sequester CO2?
In our suite of solutions for making more sustainable concrete that are using CO2. The first one and the most widely deployed one is our ready mix technology, where we're using CO2 like an admixture. And this would be something a concrete producer is very comfortable with amongst the components of a concrete mix: cement, water, sand, stone, and then chemical admixtures. So they're chemicals that you put into the concrete to improve its performance. For us, we've developed a way to use CO2 as an admixture. And what's happening there is we put the CO2 into the concrete as just another ingredient as it's being mixed. And then it mineralizes. So it goes from, well, it's a liquid CO2 injection. So you get a mixture of solid and gaseous CO2 mixing in with the concrete. That in turn forms calcium carbonate when it is reacting with calcium available from the hydrating cement. The calcium carbonate happens to form in a dispersed nanoscale particulate form, and that can improve the compressive strength of the concrete. So as a concrete producer, if you've offered them a way to improve the compressive strength of their concrete, they're more concerned about most concerned about the design strength of the concrete and making sure they do not go below that design strength. So if you've given them more strength to play with, this gives them an opportunity to be more efficient with their materials. So if they're only concerned in the performance of the lowest end of the bell curve, if you've shifted everything up a little bit, they know that they can safely use a little bit less cement, and that drives both two things for them. The sustainability aspect, we know that when you produce Portland cement, the CO2 footprint is around 900 kilograms of CO2 per ton of cement sold. And if you're just using less cement, you're avoiding that CO2 that's associated with the cement that you're not using. The second thing for the concrete producer is that the cement is one of the more costly elements of their concrete mix. So if you can drive that down, and our producers are doing so, 4, 5, 6%, or even more in some cases, if you can drive that cement loading down, that is monetary savings on that batch of concrete. But the important thing is, as mentioned, you haven't lost any performance. If you've bumped up the strength with the CO2, made a adjustment to the binder in accordance to that strength improvement, then you have a situation where the strength is not changed. It's the same strength you had before, but you've just got there by recycling CO2 and a more efficient use of your cement.
So I think another thing that I've always thought was interesting about CarbonCure is, if I come back to the cement producers and other industrial manufacturers, often one of the things that we hear a lot is we can do more when we see evidence that our customers will pay a green premium. But you are sitting in the middle of this, and you aren't. You must be charging some element of green premium, but you're able to sell that in a way and show that in a way to the client that makes sense, really makes sense to them. So out of all of those benefits that you talked about, when people ask you about the product and the green premium, what is it that in the end is often the win for them, like the ultimate kind of, oh yes, that's the thing I can grab hold of that makes this investment worthwhile?
The standpoint of developing and commercializing technologies, we've always listened to our customers. And you go back 10 years or more when this was first being developed and taken from the lab and into a customer environment. Having sustainability as your only offering was always going to be a hard sell. And this is where the idea of green premiums come in. For us, though, we have to recognize that if we want to scale this technology, it can be a hindrance. So we're not the people selling the concrete. We don't tell the producers how to price their concrete. For them, with our technology, they certainly have the opportunity to offer more sustainable concrete without the green premium. They have the savings from the cement that comes with a cost. They have our technology that is licensed. We come up with licensing terms that make sense for both us and the producer. We want them to use the technology. We want them to drive carbon reductions. We want them to be able to find those economic efficiencies in their operations. And if you do something that kind of puts them in this corner where they have to add a green premium, then that limits the market. If the decisions on concrete purchasing are largely driven by price, up till now at least, then if you see something that's a little bit more expensive, then that's going to give you a little bit of pause to make that commitment. But if you have something price parity and you're driving down the carbon footprint, then it becomes like, okay, I'll take the more sustainable choice because it's not going to cost me anything. So that's born of these early conversations with the concrete producer and recognizing that if you're going to get those scalable solutions that accelerate, they need to make sense on multiple levels. You can't just say, we have the lowest carbon thing and everyone should buy it. That's maybe gonna not work as easily as one would hope, or have other barriers. But if you can, for us, I think one of the big advantages was working within the existing supply chain as a retrofit. You have an incumbent industry that's been, experts in making concrete. And if you come in our case, and say, do what you're already doing, but now just retrofit in this CO2 injection system, this one small change to your concrete plant. Now you can unlock these benefits in the performance. If you want to improve the strength, you can unlock the benefits to your bottom line if you're reducing costs, but further, you're unlocking market differentiation. You're going into the marketplace, which fairly or unfairly can be a little bit critical of the CO2 impact of concrete. Now, inherently, that's got nothing to do with the material. The material has a low carbon footprint, but we're just using so much of it that if we can come into that marketplace with, and these would be our concrete producers, come into the marketplace with ideas, with new concepts, with an authenticity of saying, I'm really trying to reduce the carbon footprint. I'm modifying the materials I use or the procedures I follow, within the accepted framework of codes and safety. But I'm making these choices to be more transparent and drive down the carbon. The building owners and the architects, they respond to that. They know they have to use concrete. So why not use the concrete that has the lower carbon footprint? So this is kind of something that happens when you get involved in some of these novel technologies, that you can differentiate yourselves within that marketplace.
Yeah, I think it's interesting that it's not, because you're not just saying do the right thing and pay more. You're saying do the right thing. It's a stronger product. You can actually end up using less overall, and it's a value add to your end user. It's a kind of a stacked set of co-benefits, isn't it?
Exactly. I mean, the sustainability and scaling comes with adding value to the supply chain. Again,
I mentioned at the start that I was really excited about having CarbonCure on the podcast. And the other reason is quite often I find I'm either talking to really early stage companies or kind of very mature industrials or investors. And actually, again, you have this sort of interesting lens, I think, in that, yes, you're a disruptor and yes, you're a growing company, but you have already been through the early stages of scaling. And I'm just wondering, what as a team, and what have you personally learned during that, going from edgy disruptor, just trying to get the first meetings, through to where you are now, where, you're winning prizes, you're gaining clients. What have you learned from that journey so far?
I think you've captured it there, where in terms of just a low TRL idea, that we've gotten past that stage. We've gotten to a stage where we are growing and scaling, and that's the mode of the company right now. Developing more technologies for the concrete producer, developing a team to bring them to a reality. Along that way, I think the important thing has been going back to that idea of scalability, when you're talking about the carbon problem, you get into a concept called the time value of carbon, saying, if we look at the amount of CO2 as basically a finite amount of CO2 that can be emitted before we hit a tipping point, and this gets into getting to net zero or even getting to below net zero, is making sure we don't reach that tipping point, that it is more meaningful to get those carbon reductions now than it is in 30 years when it's could be too late. So we know that if we're developing these technologies that work within the value chain to drive down the CO2 footprint of concrete producers, we can't, wait 15 or 20 years for them to be impactful. They have to be impactful today. So that has, when you start developing an innovation, the first people that you're going to work with are those, leading edge innovators who will just try just about anything. So they have been important, helping us refine the technology offering, understanding how it's going to work for the next tranche of customers whose needs and interests will be a little bit different. So I think we have always been able to learn from the customers. We have a diverse team that even comes from outside the concrete industry with a world of ideas that help drive the conversation forward, both from conversations we have on the sales side, or is it on the policy side, carbon reduction conversations, what can we contribute there? How can we help this whole industry turn the ship to reach those lower carbon goals?
I know, one of the ways in which you, not you personally, but the conversation that you guys bring to the table differs perhaps from how some other solution providers in the space present, is that you talk about the permanent removals, and permanent removals is kind of key to your thinking and to the technology that you develop. I'm wondering, to what extent do you see or hear kind of the harder to abate sectors really talking about permanent removals, or do they just, sometimes, I do hear some of them talking about it. Some people seem to just talk about carbon capture and think that's everything. I don't know. I guess my question is, are you hearing that interest in permanent removals is kind of really more of a conversation for the hard to abate sectors yet?
Certainly the concept of carbon removal is something that is, developed in the last 5 years or so, where the terms are still kind of evolving, and what people want out of carbon removal is becoming more clear. Working within the cement and concrete supply chain as a CO2 utilization company means that we're following the CO2 mineralization pathway for converting CO2 into something else. And that is always going to be the most stable and durable CO2 removal option. You're not putting it into a chemical or a fuel that you're just going to burn, and it just kind of the CO2 molecule goes around in circles between the environment and the product. It's not going to go into a tree that, trees on the long term, they do decay and so forth. So you get into the, millennia scale CO2 removals. And what you're doing basically in this format of mineralization within concrete is you're forming calcium carbonate, which is, limestone. Mountains are made of limestone that have been around for millions of years. So we do have that level of permanent removal in our technologies. In the broader industry context, I think if you go outside of cement and concrete and some of the more impactful industries, they'll probably just move to lower carbon fuels like green hydrogen, for example. And that will always be an option in cement production, but the process emissions from calcining limestone to make cement are just a fact of the chemistry, where you will be, if you're going to heat up the limestone to drive off the CO2 from the calcium carbonate to get the calcium oxide you want, then you'll always be having that as a CO2 emission. So that can't be just fixed by swapping in green hydrogen for coal or something like this. So that will be the challenge. And if CO2 capture and storage is going to be a part of cement production, that's going to be why. We do see some other efforts coming out of the lab right now that are looking at alternate pathways of making cement. So is it going to be something that's an electric-based cement rather than a thermal process? Is it going to be something that is using calcium silicates instead of limestone calcium carbonate as your feed material? So we'll start to see options like this giving us the same material that we wanted, just with a different processing pathway.
Okay, and then I know again, one of the things we talked about when we were sort of having a chat ahead of this was the 500 megaton roadmap that you guys have laid out. Obviously, it's central to your business to have that concept in place. What does that mean to you? What does that ambition mean? What does it mean for how you're going to scale from here, do you think?
For us, or for any company operating in this kind of space, you kind of have to have a motivating North Star that defines your direction of travel. So for us, the roadmap is really an exercise to understand the opportunity, to say, if everything goes right, this is the potential impact that could be assembled through our suite of technologies. So everything we can do to increase the deployment of the technologies, increase the use of the technologies by the people that have them, increase the CO2 reductions that these technologies can provide, they all drive towards the overall carbon reduction goals of the company.
So are there specific elements of that, the megaton roadmap? I just love that phrase, the megaton roadmap, that kind of particularly grab you, like that you think, oh yes, this idea, this concept. What is it that stands out for you personally from that forward-looking plan?
With our suite of technologies, we get starting with the ready mix technology, which is like the CO2 as an admixture. You can stack that onto our other technologies in the roadmap. The second being the reclaimed water technology, where a producer's waste product of cement-rich slurry can be treated with CO2 and then recycled back into the concrete, thereby saving the mineralized CO2 and providing another cement reduction opportunity. And then you can talk about the production of recycled concrete aggregates with mineralized CO2. Each of these offerings is a way to mineralize CO2 into the concrete, operating within the existing material supply chain and technology stack that a concrete producer will have. You're not going in there and telling them you need another mixer, you need to develop this special curing thing that happens in this building over here that you now need to construct, or you need 3 more silos to hold your materials. In order to be scalable, you just have to kind of make it deployable now and then start to make it appealing. So this has been kind of where we look at the suite of technologies, just saying that they do complement each other, but more importantly, they complement the other things that are going on in the concrete conversation. When you go back to talking about reduction wedges, this is not an either or type of technology. It is a technology that complements and fits in within the supply chain and their efforts to reduce carbon. We don't have the luxury in the industry of having a silver bullet that's just going to be the one thing that's going to solve everything and we can deploy it globally in the next 5 years. Like, that's not going to happen. So we do have this conversation around a number of different things that can all work together. Some of them may be more regionally specific based upon the material supply chain, but we don't have the luxury of saying that, that's not good enough. It's all good enough. It's all going to work together. So we just want to be helping drive that conversation forward and be a part of the solution.
Well, as I said at the start, it's CarbonCure as a company, I just think it's been fascinating to watch, even in the last couple of years, which is the little bit of time that Decarb Connect has been around for this conversation. So, it's great to hear more about it. And I'll make sure that for people who are listening who would like a bit of information, further information on the different suites, different products within the suite that CarbonCure have a look in the show notes, because I'm going to ask Sean to share with me, some good links and good information so that you can build up your knowledge there as well. And Sean, thank you very much for coming on today. I can only imagine how busy your schedule must be with the growth plans and the work that you're doing. So it's very much appreciated. Thank you.
My pleasure, Alex. Thank you very much.
Many thanks for listening to the Decarb Connect podcast. We work with clients across the industrial sectors, specifically those who are tasked with decarbonising the most energy-intensive products and materials that we use every day. If you have an interest in learning more about either our members network, our reports, or our event series, do get in touch with us at decarbconnect.com. Or if you'd like to take part in the podcast, email me, Alex, at ac@decarbconnect.com. Thanks for listening.